Hello, in this short video we will check a brief overview of the data ingestion pipeline, how sensors transfer data to the Edge Analytics engine, and how it transfers data to the data warehouse. The Edge segment of LC platform includes sensors, smartwatches, smart scales, location sensors, proms, etc., and a Raspberry Pi, which acts as a hub for collecting data from health application for quality of life assessment and Msphere Locks gateway. It also hosts a REST API where the apps post the sensor data, the Edge Analytics engine, Java app, a Redis DB, and an MQTT client. The sensor data feed, which for the purposes of this demonstration has been simulated by a dummy data generator, is analyzed by the Edge Analytics engine, that includes Edge pre-processing algorithms. For this demo, the algorithms are responsible for detecting faulty sensors and overactivity events. The process data is stored in the temporary Redis DB, while the MQTT client publishes the process data to MQTT topics. In the demo, the topics are raw, faulty, overactivity. Flink, hosted in the cloud, connects with the MQTT client and is then responsible for the aggregation, real-time, and batch processing of the data. The process data is then forwarded to Apache Kafka. The Kafka client publishes the process data to Kafka topics. Now, let's proceed to the video demonstration of the components, which have been deployed to the dev environment using the C/CD pipeline. Let's build the Docker container for the Edge Analytics engine, Redis DB and REST API. We've created a set of dummy sensor data generators, number of steps, time outdoors, BMI, that make post requests to our API, simulating the real process. Data is published via MQTT. We start the MQTT subscriber, and we observe that it receives all the published data under different topics. As you can see, the data schema includes information about the sensor, the values and the hard-coded limits of these values, the patient ID and a label. The label is extracted using the Edge Analytics engine, and refers to faulty sensors, overactivity events, and raw data. The process data is stored in different Redis DB lists, according to their labels. The first example shows the record stored in the faulty list. As highlighted in the video, the record has been correctly stored in the corresponding Redis list. The second example shows the raw data that is stored in the raw Redis list. At the same time, we observe that we also have some overactivity events that are also stored in the corresponding Redis list and under a specific overactivity topic in MQTT. Now let's move on to the cloud. We now see that the Flink instance is up and running in the development environment. The job referring to the analysis running on the cloud is the demo process, as shown in the video. Here we can see the different event processing tasks. The two on the right receive the faulty and overactivity data as input, and without any further processing we push them to Kafka. The one on the left takes all the raw data as input and splits them into data coming from sensors, first one on the left, data coming from location sensors, middle, and to a process that performs a correlation analysis of the data, right. Finally, we perform a 5-minute window statistical analysis for the data coming from the mHealth application for quality of life assessment, producing the min, max, average and standard deviation of the corresponding sensor values. The table below shows the records received and sent, where most probably the lowest value refers to overactivity data that we haven't yet received. At this point Flink has pushed the data to Kafka, and we can now see 3 Kafka consumer instances, each one consuming a different topic. The first one on top shows the raw data, while the second one shows the faulty data. Faulty sensor data refers to sensor values that are above or beyond certain predefined limits. The last one shows the results of the statistical analysis which has been previously performed on a 5-minute sliding window for mHealth application sensor data. All the components that have been presented on the video have been Dockerized and uploaded to the development environment using the C/CD platform.